Everyone, August 28th. Alright, let's get down to it. Do we have any more things? Oh, we done this one yesterday, so we don't need any of this. We still have this to go through. Ugh. We do. Let's turn off all this. Alright, minimum penalty for a shop. You're given the customer visit log of a shop represented by a zero-indexed string customers consisting only of characters n and y. If the ith character is y, it means that customers come at the ith hour. That's yes, whereas n indicates no customers come at the ith hour. That's a no. If the shop closes at the jth hour, the penalty is calculated as follows. For every hour when the shop is open and no customers come, the penalty increases by 1. For every hour when the shop is closed and a customer come, the penalty is increased by 1. So if the shop is open and no customer comes, or the shop is closed and a customer does come, they'll have penalty. Return the earliest hour at which the shop must be closed to incur minimum penalty. Shop closed at the jth hour means it closed at the hour j, which means what we want to find is an index j such that wait, hold a second, they changed this. It looks different. Change the font. Huh. Anyway, so we want to find an index j such that from j to the end, you'll be able to calculate a penalty, right? And we want this penalty to be minimum, and we want to find the earliest hour. Closing at the 0th hour. When you close, then to the right hand side, all the y will incur penalty. On the left hand side, all the n will incur penalty. So it looks to me from the current, it looks to be a sliding window type of thing. The earliest hour at which a shop must be closed to incur a minimum penalty. So if you think about this as a sliding window and you have y, y, and y, right? And then we start closing like this, and then we have a p left, a penalty left, and we start with 0, and a penalty right, we start with 0. Right? That's the starting point. Now if this is turning, and we need the penalty right to be adding up everything, all the y's, right? So this will be 3. That will be penalty 3. That's at the start. I mean, at the start, we don't have any penalty coming from the left hand side, but on the right hand side, we will have penalty. Then you shouldn't draw this, right? So this is basically, we can compute penalty left, and then when we close at this, which means this remains open, so we just count if there's any n. If there's no n, penalty is still 0. And this, we remove a y, so penalty becomes 2. Now we come here. If it's n, we need increment, but it's not n, so it's just still 0. And this is n, so we decrease, so the penalty is be 1. All right. And then if we close it here, zero, 1, 2, 3, 4. If we close here, we'll incur penalty in this, right? Because this, so if we have an n, we need to add it. If it's n, we don't, so it's still 1. So this is penalty is still be 2. And of course, you can close at the end, right? If you close at the end, so whenever it's a y, we need to remove it. No, whenever it's a y, we don't do it. If it's n, we plus equal 1, so this is still 1. And we remove a y, so remove 1, so it'll be 0. So this is also penalty is 1. So this is be the best. Okay. Let's do this. I think a sliding window will work. Well, we need to. Penalty left is gonna be 0. Okay. Penalty right equals to 0, but we have to go from for int I equal to customers.length minus 1, I large equal to 0, I minus minus. If it close, each time is a y, right? We can say if customer dot char at I is equal to a y, penalty right plus plus. Okay, so now I have penalty right. Then we're gonna say for int I equal to 0, I smaller than customers one. Let's start length. I need to also set int res. Min penalty, min p equal to pr. Okay, and int res equal to 0, right? Closed at 0's our penalty when closed at 0's hour. Now we can start. For each one, if customers dot char at I minus 1 is equal to, if the previous one is a n, is a y, start with y, right? If it is a y, then PL, penalty does not increment, but penalty right shall decrement, right? Penalty right shall decrement. So this one will be minus minus, else, which means it's then we can say penalty left will be plus plus. The penalty right will not change, right? And then we say if PR plus PL is smaller than min P equal to PR PL, and res equal to I is the new smallest, right? If we find something that's small, then we keep doing this. Once we're done, we return res. Okay, let's check this. Looks about right. We're gonna do, oh gosh, of course we try the single one. Okay, if this passes, then we're gonna submit. Looks solid to me. Oh, done it before. sliding window. Do you consider this a sliding window? I don't consider it a sliding window, but do we even consider this as sliding window? I don't know. Is it considered sliding window? Two passes. Oh, that's exactly what we're doing. One pass. Earliest hour with the lowest penalty. Thus, the only thing that matters is the penalty of the hours relative to each other, and our initial reference point is not significant. Wow. That is true. Huh. Good. Yep. That was true, right? You do not have to it's for 28. No, it's for 29. So, update from the official solution. There is no need to pre-compute PR. Compute the exact value of PR. We can simply set PR to 0 and just compute a relative penalty. The penalty computed will not be accurate, but its relative value compared against each other is correct. And since we are only concerned about the relative values, this will suffice, which means I can just move this entire thing. Yep. I guess this one's faster. Oh, that's nice. Okay, so that's that. Done. All right, let's do this. N items each belong to 0 or 1 of n groups, where groups I is a group that the ith item belongs to, and equals if the ith item belongs to no group. And then we need to we know how to do this. it's a topological sort, right? We know this. So we build the graph. We build the graph for the items, and we build a graph for groups. Ooh, how do we build a graph for groups? Before items. And for all the -1, it's going to be -1, -2. I'll just keep adding this as fine, right? And then we'll build a group map, right? When in the map, each value map to a group. Okay, each value, each item need to map to a group. Each item map to a group. I can do that. And basically just change the group. Yes, we'll change the values in the group, and we'll do a graph for items, a graph for that. And then for the graph, we shall do a order, right? We shall do an order, which is totally fine. We'll do an order, and we can order all the groups, and we can order all the items. Okay, so once we have all the order, right, coming out, it doesn't really matter, we have all the order come out, then we have to put those in a group. That's fine, can do that. All right. The whole point of doing this, okay, it's not really to solve the problem because we already solved it. The whole point is to practice. Okay, the whole point is to practice. We just need a topological sort, right? But let me grab the group first, and then we change the value of m. Group I equal to 0, I smaller than group dot length I plus plus. Okay, and we'll say int none group will be -1, right? So if we find a -1, none group will be, and we will find the total number of groups. Total number of groups. Num groups 0. Okay. That's not the way to go. Number of groups. We'll handle the number of groups later. For now, I just want to say if group I is smaller than 0, group I equal to none group minus minus. So that will get the groups, okay? And then we're gonna call make graph. So we need to do hash set hash map integer and has to be a what? A set, hash set, integer. Okay, so when you say item graph, okay, and for before items, right? For int I 0 I smaller than 4 items dot length size I plus plus. Okay, then int no list integer before equal to before items dot get I. Right, now we have before item. Then we have to go through them for int b of befores. Item graph, who leads to whom? Dot compute if absent. What's the key? Is it be B? New hash set. Oh, I think it's key. Right. This one dot add before add I, because that's the before, right? So this has to be before this, or this leads to this. So whatever we have dot add the current node, right? That's the before items. And we should also do another thing, not item graph but group graph. Right. Okay. So group graph dot compute if absent. What is that? That should be groups group B. That give me the group ID. Right. And a K new hash set dot add I group I. So this will create the two graphs. Once the two graphs is created, the next thing we need to do is call private array list integer. What's the thing that you want? We call it topological sort. Okay. Then we need a graph. Hash map integer hash set integer graph. Okay, now we need to figure this out. Okay, so what do we need? We need a hash map integer. Actually, we don't need hash map. All we need is have a array list, a queue, right? Shall equal to new array list. That's fine. And then we go through the graph. Right? We go through the graph to find which one has 0, right? We go through the graph. Actually, no, we don't go through the graph. We need to go through. What do we need to go through? We need to go through all the nodes, right? We need to go through all the nodes. Should we pass the nodes in? I think we should. Nodes can be an array list, integer nodes, right? Then we say for int node of nodes if graph dot get or default node collections dot empty set. Wait, how do I use this? How do I use empty set? I forgot. No, I just want to use new, right? Promotion use new. I don't think so. Huh. Get or default. No. What the? No instance of type T exists. Conforms to. I don't understand. I'm gonna say that size is equal to 0, or we're gonna say dot is empty. Then q dot add node. Those are the ones have no in degrees, right? Those are the ones has no in degrees. They only go out. Actually, I want in degrees. And this give me in degrees? Wait, hold a second. If the graph is previous to the next, previous to the next, right? Then these point to the next. Are we supposed to find the ones with 0 in degrees or 0 out degrees? It should be the 0 in degrees. Right? It should be 0 in degrees. Which means these come to this. Right, I have something, we'll go to this. Then this has in degree. Huh? That doesn't make any sense. How do you calculate in degrees? How do you calculate in degrees? You give me a graph, right? It's a directed graph. Are you telling me that the graph should be different? It's not going, but the reverse, right? These are the before for this. Then we can find one with 0 in degrees. But oh, that's strange. Wait, hold on. It doesn't work anymore. We have a graph, right? This is at 0 in degrees. These have in degrees, so whenever this goes on, then these nodes in degrees into -1, right? But how do I know who has the 0 in degree to start with? I have to go through the whole thing to find who has 0 in degrees. But I still haven't solved this problem. I don't know what this one is wrong. How do I use this? Oh, I have to say no. It's still not right. Wait, are you telling me it should be empty hash set? There's no empty hash set. Empty. Oh, I see. I should not say hash set. That should just be set. There we go. This one, that would be right. No? Oh, wait, hold on. This one. Set. There we go. Okay, it's just a type thing, but we're not going to do it this way. We're not going to do it this way. What we need to do is to find their in degrees. Yeah, unfortunately we have to do this. So hash map integer and integer in degrees. Okay, then for each node, all right, then for each node, then say for 3 for int current and parent child. No, this is parent. All right. For that, then we can say in degrees dot put if absent child 0 and no, I don't want to do that. I want to put child in degrees dot compute if absent child 0. Right, plus 1. This says we have this child, we know has a parent, so its in degree will be whatever it has, right? So shouldn't we just call this get or default? All right, I think that's the one to go. Just get the default, which means if the child is not in there, then it can be 0, then it will just become 1. All right, otherwise will be whatever it is, will be plus 1. So once we go through this, we get this in degrees, and then we can say for int parent of nodes if in degrees dot get or default parent is 0, q dot add parent. So now we have a q. Okay, we say while q dot is empty, while it's not empty, right? Then we can order them. Okay, so we need to have a array list integer order new array list, right? Ooh, we need a pop left. Do we have pop left? Q dot so maybe this has to be a list. Do I have a linked list? I do. Then q dot remove. Hold on, I want to remove, wait, hold on, what's a Q? Java Q. Yeah, I remember I saw this yesterday. Yeah, linked list. dot remove. Q dot remove. But why is it not right? Cannot resolve. Oh, I have to change this to Q. Head of the queue. Oh, nice. Okay. So the queue, you implement it via linked list. Okay. Then, while queue is not empty, then we're gonna, just grab whatever we have. Current, or you go to this, right? And then we'll go through all of its, so for, we call it parent. That's okay. For int child of graph dot get or default parent collections dot empty set, right? Now we have the child. So each child is in degrees dot put child in degrees dot get or default. Now it should have child. I think we just get child -1, right? And then if in degrees dot get child is equal to 0, then q dot add child. Right, so we do all that, and then once we're done, we say order dot add parent, and blah blah blah. Once we're done, we'll return order. So that is order. So after we get the two graph, we can say array list integer item order equals to topological sort. What do we need? We need a graph. So item graph, and we need nodes. And we just realized we don't need this nodes. We can just be we just need it to be, that's fine, I guess. The nodes. Ugh. I mean, technically we don't need nodes to be an array list. So maybe for this we only need this to be int, right? And here we just need to be an int, and we just say int item nodes equal to new int how many. We have n, right? And then for int I equal to 0, I smaller than n, I plus plus, I equal to I, right? And then we do item nodes. Perfect. Now we have the item order. And then I need a hash map integer and array list. Oh, we can just call it list integer. We call it groups. Right? We'll call it groups. Then what? Then we go through the item order. Right, we go through the item order, and then we say for int item of item order, right? then groups dot get or default item. No, should be the group. New array list. Alright, so we get this dot add item. Alright. For each item in the order, no, it's not. It should be compute if absent. We get this and then we add the item. Right, now we add this item, and the next time we see, so each group compute if absent. What does compute if absent mean? What does this one do? Attempts to compute this value using the given mapping function and enters it into this map unless null. If the mapping function turns null, if the mapping function self throws exception, blah blah blah. Yeah, I think that is the one, right? You compute it and then you add it to it. Which I think this one can be simplified to in degrees dot compute if absent child. Absent will be 0. Oh, but you cannot plus 1. Right, you cannot plus 1. Because this does return integer. And if you plus 1, you have to, yeah, it doesn't make any sense. It has to be put. This has to put. But this is different. Yeah, because if you're changing the values, this way you don't change the values, you just add. Right, now each group will have this. Now we have the group. Right, now we have the group. So here is topological sort of the items. Right? And now we go topological sort of the groups. Now we have the groups. Now what? Now I need int group nodes groups dot size, right? Then we say for int g of hold on, I think I have this Java hash map keys to array. I forgot. To array hash key set. So I can just say groups dot key set dot to array. This won't work. Doesn't work. Oh, it's, oh no. This has to be integer. No, enter. It's still not right. Oh, I have to do this. I remember. New integer 0. Yep, which means this has to change to integer, which means this one's not right, but that shall be easy to fix. This is easy to fix. Yeah. So this is the group nodes. Then we can say array list integer group order topological sort group graph and group nodes, right? Okay, now we have the group. Now what we need to do is to build to add all, right? So we can say we're gonna return int, oh my goodness, int with the values in it. Okay, it's fine. Int this res equal to new int n. Okay, combine the result of both topological sort. Okay, then we just need to go through the group order. So for int g of group order, then what we can get is the nodes, right? The nodes is going to be a list. So list integer equals to groups dot get g, right? Then what we need to do is can we turn array list, hold on, Java array list to array? I think it'll be easier if we use a list. Alright, I think it'll be easier. Then I can just say res.add all groups.get g. Then I'll return res.toArray new toArray int. No, this doesn't work. Yeah. We'll call this res, that's fine. Then int res array equal to new int, what's that, n, then for int integer, yeah, it doesn't matter, it's int, r of res, no, I equal to 0, I smaller than n, I plus plus, right, res array I should equal to res I, and we'll return res array. That is not right. Get. All right. Now we can try, see if this is right. Ooh, where? That's interesting. For length 2. What? Okay. Is this one fail? This one does fail. Oh. Oh, you forgot to consider. Wait, hold a second. Yeah, there's something I forgot to consider, but let's make sure this one's correct first. What the hell is wrong here? How to print a... I forgot. Print array. Array to string. Huh. 0 and 7. That's interesting. But something is not right, boy. Okay. Group order was not right. The graph might not be right. That's before. Interesting. I have -1, -2, -3, and I have 0 and a 1. What the hell happened? Groups 0, -1, -2, -3. That's correct. Okay? Groups is correct. How about group graph? Group graph. That's in the problem. Group graph is not right. Group graph. The before nodes. I get a before nodes group. And I add zero to zero. That doesn't make any sense. Oh, that does make sense. That does make sense. Oh, if they're not in the same group. Holy crap. So it has to be not the same group. If group B is not equal to group I. Yep, I forgot about this. Then we do this. Yep. Then I have it. Okay, so let's remove this. Remove this. But still, I forgot. There's one more thing we need to do here. To make sure that there's nothing, like everything, like the order has to be the same. Yeah, return, say if order dot what's order size is equal to nodes dot length. Otherwise we shall return let's do it here. Well, first of all, I'm going to change this. Okay, and then this has to be order the length, not size, equal to nodes dot length. If it's equal, we return order. Otherwise, we return new array list, right? And then when we get out item order, if item order dot is empty, then I return new int. Right? Impossible. Now error loop in item graph. Same thing. Group nodes. Group order. Right. So this is a group order. Loop in group graph. Okay. Try one more time. Now I'm gonna use both. Okay. 走你. Yep. Ugh. Bad runtime, but call it. I want to call it Java implementation. Okay, so that will be it today. Quite an effort, right? Quite an effort. We are actually going to, I'm actually going to do it. Alright, we can do 1203 Java. There must be some easier way to go through this, I don't know. Just haven't done enough Java to figure this out. Alright, but that will be it. We've done both. We've done Java, we've done Python. We can. What's the Python? 43%. Java. Oh, look at that. Look at that. Final. Map to int. This is empty. I'm too lazy to study this. Alright, I will end right here and I'll see you guys tomorrow. Adios.